the directionality to objects and surfaces, and frankly lines as well, that sometimes you'll encounter when you're modeling something in a scene, it is extruding the wrong way from where you think it should be. I'm going to just put this back to world top real quick. Or it's not, this starts to get more involved when you're doing some kind of higher level surface analysis. But the directionality of the surface actually is very important to orienting objects on that surface, flowing objects along that surface. Certain grasshopper commands rely on or demand, in fact, knowing the orientation of the surface, or else the command won't work. Within any object that we see in a scene here, there is embedded information that is not immediately visible that that's important. That's important to that surface. So let me see if I can find a directional situation. So if you click Analyze Direction of the surface, you can actually change on the surface itself. That's in the Surface Tools box. I'm not going to have a good command to follow this right now, so you don't need to follow on this one if you don't want to. But it's basically just showing you right now that everything is pointing. Let's do this with a single surface actually. Everything's pointing outward in that case. But you should be able to manipulate the orientation of all those things. So right now, this is saying, okay, this surface actually is, its positive direction is this way, and its negative direction is this way. In theory, I could flip this surface, and so now the positive direction is the other way. I could also, if I wanted to, right now, the UV direction, which is related to, or the UV coordinates, which is essentially related to kind of the XY coordinates of the object, the vertical versus the horizontal kind of breakdown of the object. I could flip that. So right now it's kind of in a normal orientation. Y direction is up and the X direction is right. And we have a normal orientation of positive and negative. You could reverse that so that now the X direction is negative and the Y direction is negative. You could swap the UVs, so suddenly now the X is the Y and the Y is the X. Why am I telling you all this? All this is to say that every piece of geometry that you make in Rhino has some aspect of this information embedded in it. And this will become important for us to understand as we start to build more complex geometry, understand more complex commands, which we'll cover off on in future classes. But back to our C-plane projection here real quick. Let's just quickly draw through using the C-plane. So I'm going to go back to my C-plane command. I'm going to say orient to this surface. I'm going to say extrusion surface face here. So now, in theory, whenever I draw a shape, rather than duplicating the edges or offsetting the edges, which is a fine way to do it, I could draw this shape from left to right, right in perspective on this surface. I could offset that shape like I did before. That's totally fine. 2 inches. We could divide. Actually, we'll want to divide the edge still. Oops. Extrusion edge, we know 9. And again, just in this case, there's not like the added step of needing to make sure that your object snap is associated the right way, or it kind of simplifies the process for you. So in this particular case, we know that there's 8x, 1y, 1z. The spacing of each is this. So we have that. Here's another thing that we could do. Just trying to think of an efficient way to do this. We could. I jumped a step there. I probably wanted to create a solid of this before just going all the way down. So in this particular case, since the C-plane is perpendicular now to our, I'm going to turn project off so that I can hit both sides of this. There's my extrusion. I could extrude this surface both ways rather than the offset command that we did before. We could say extrude both sides, and we could extrude 1 inch both sides, and suddenly we have a solid that's built a little bit more efficiently than, say, the first way that we did it. In this particular case, I have a solid here right now that is defined by this outer line, but let's, rather than creating a new frame out of these two extruded surfaces, let's just extrude this one and do a Boolean difference to this shape. Boolean difference. So now we've created that, and then we can do our, if we want to, we can do our array like I had shown before. Now we have an object that makes more sense. So 8 in x, 8 in, or 1 in y, 1 in z, and then space it accordingly.
So you know how like you did the like an extrude command
Mm-hmm.
on like a surface, but there's still like the lines that you have to delete on the outside of the surface? Is there a way to like just automatically
delete the input basically would be where if I click extrude. So I've kept delete input as no.
Oh.
So if I extrude this now, but I have delete input yes, that line is now gone, and I just have the solid. So that's the way to keep it kind of clean. Again, sometimes you want those reference points to propagate it in the future, but that's the quick way to delete that reference geometry. So another way that we could make glass, obviously, we could extrude this surface up from the bottom. Just this one here, not both sides. So I can either click up here, or I can also just type B, enter, or spacebar, and then that will let me toggle some of those subcommands right in the command. So we have this poly surface. What's happened here? And I deleted the input, that was why. There we go. So I have this poly surface. Again, scale 1D very often comes in handy just to quickly like get something in space. Oh, I scaled it accidentally. Scale 1D. Very often you'll return to that command. So in this particular case now, instead of doing the split command like we did before, I could select these mullions. Let's group them. Control G. So now what I've done with this is the group command lets me keep objects on a layer, keep objects as discrete elements in the model, but just for the sake of model organization, it lets me just literally group elements together so that I can move these around all at once. I can operate on these all at the same time, even though they're not connected by one another, which comes in very useful, again, when you're kind of identifying different systems that you're trying to work on in the drawing. So I've grouped these together, and one way that I could clean up this glass is I'm going to actually copy these mullions just on top of themselves. So now I have two sets, as you can see, group 1, group 2, of these mullions. And what I want to do is actually use them as a Boolean difference for the glass. So I've selected the glass, Boolean difference. Now I'm going to choose this one set and then click enter. And now it should have created a series of discrete glass panels. And now we don't have to go through the tedious process of capping the edges and cleaning up the stray lines that are hidden below the mullions. That's all gone. That's all been deleted. And the Boolean difference cleanly closes the geometries that it's acting on. So I've been bad with my layer management here, so I will select these items and make sure that they're on the right layer. And so another couple just like interface things that you might be interested in toggling yourself. You might notice that my I'm just going to move these to the frames layer. You might notice when if you middle click the zoom scroll, a separate menu, kind of a sub menu, comes up with essentially a series of commands that oftentimes relates to commands that you've recently used or are commands that are commonly used. You can program this pop-up to have any types of commands in it that you want. It's just a quick way to easily reference buttons that you use often or commands that you use often. So that's that is one macro that you can use for the mouse zoom. Another one that you can use that I find very, very useful in navigating around the scene is, rather than having to type ZS every time to zoom in on the selected object, say we have just a whole complicated sequence of these things, who knows, all over the place. And I got to find this one and type ZS, and then I zoom in on it. You can also go to your Properties menu in File and adjust some of the macros that are attached to your interface. So under Mouse, which should be down in pretty far down in Rhino options here, Mouse. So right now the mouse group select is combo. That's totally fine. Middle mouse button has a couple things here. So you could actually program it so that it's the most recently used commands pop-up menu, which is what I was describing. What it actually is right now is a pop-up, basically a default pop-up that shows specific menu items that you can edit. You can also run a macro, which in this particular case I'm just going to show one. You could run any one you want. Say there's a command that you use all the time as it relates to navigating the scene, and rather than having to type that in every single time or not have access to it on the mouse, you can just program that into the middle button. So in this particular case, I'm going to type zoom selected, and we're going to close out of this. So now, if I'm in the scene and I just click the middle scroll, it will zoom select for me on any object that I want. And I don't have to do the ZS every time. And so it's just very, very easy to navigate around the scene. I'm not, again, your sort of preferred interface, how you use it. If the pop-up is more useful for you, great. I find that like speedy modeling is assisted by being able to quickly get to a point in the scene, zoom in on it, make sure the orientation is right. So that ZS command is helpful in that respect. You can, let's see. So we've created this new set of frames. In this particular case, we have a door in it, so we'd probably want to continue to kind of draw maybe using the C-plane that we already have. But in this case, let's say the door it's probably 7 feet tall. So we could scale 1D. This is also, again, I'm showing this all in perspective, but we could probably even a little bit more efficiently draw some of this stuff in the top view or the front view, depending on, again, the orientation of the model. So keep scaling that. So the next thing I'm going to show you is aliases, because this is driving me crazy. So scale 1D this shape. Let's see if that actually worked. Let's see if what we were doing in 2D actually didn't distort in 3D. Looks like it was okay. So now we, in theory, could offset these lines, make a little transom. Extrude curve. I should have deleted input, but we'll just delete it there. So another way you could type match layer while you're in and then select an object that you want it to become. That's sometimes quicker than going over to the layer menu and right-clicking on whatever you're trying to change it to. Extruding surface here, again, just different ways that we can do this. Why does that not work? The input, no. So actually this, yes, this did. So if I delete the input, then actually what it has done, it's melded that middle panel to the frame that I created before, which is not what I wanted to do. So I could just undo that and make sure that extrude surface does not delete the input, basically. So delete input, no. Now it creates an object on the proper layer, or on the default layer rather, and then we can scale these accordingly. Match layer. So another way that we could move those surfaces around rather than scale 1D, say we wanted to just move one side. We know it's going to be in a direction that is perpendicular to the face. So I could say move face. In this particular case, then I could select both of these objects, just the face of them. It's kind of like the stretch command in that case. Select an anchor point, and then I could move this around as much as I want without stretching other aspects of the file. So scale 1D obviously is useful to kind of quickly size an object to the scene that you're working in, but sometimes you can get in trouble with it because it requires reference points that you need to clip on to other parts of geometry. And if you're not completely accurate with that clipping exercise, it can get you in trouble because it basically it just draws inaccurately, or can distort the model if you're not careful. Control Shift.
Yeah, you try pressing Control Shift, and like when you start to try pulling, like how you pulled the geometry.
Mm-hmm.
You did that. I don't know. If you do Control Shift.
Control Shift, huh?
If you press it together.
Okay. Doesn't look like, well, maybe I'm misunderstanding. It's doing a similar.
Like Control Shift, and then you can hit like. I guess that's two. And then you can just move, but that's two.
It's so a lot of these commands, and as we'll see with potentially with Grasshopper later in the semester, is a lot of these commands are actually made up. The code is made up of a simple sequence of, again, more discrete commands, right? So move face is actually a combination probably of those very things. The actual move after you've selected and isolated this object, you could probably create a move face command yourself manually. It would just be less efficient. So Boolean difference this. Okay. So another thing I'm going to show you guys, again, just kind of a smattering of little commands here, is the aliases. That's helpful. Okay. So again, I've been typing through all these commands. It's a little bit inefficient. Sometimes you see me messing up. So there's a wall that we got going on. Let's see what that looks like. Great. So I've been cycling through these different commands. I want to simplify my input process for this so that I can be a little bit more efficient as I model. I'm going to just reset C-plane to the world bottom. So if we go to File, Properties again, and if you go to Aliases under Rhino Options. So right now, every shortcut that is in the default of Rhino is listed here. There are other ones outside of this, but these are, if I typed in C right now, it actually doesn't do a copy necessarily, which is a common command to associate with C, but it does a select crossing, a different command that works with intersecting lines. P is planar, O is ortho, M happens to be move. Okay, that makes sense. We notice here that zoom selected is ZS, like we had said, zoom extents is ZE. I can add any list that I want to this that essentially allows me to create new macros and shortcuts for basic commands. So let's say that polyline, which is a very common one that you're going to use. Let's say I want to create a shortcut for polyline. So I say new, I'm going to say PL in this case. And then I'm going to go over to here and type polyline. Another one that we could do, extrude curve. We've been doing that fairly often. We could do EC, extrude curve. We could do extrude surface. Some of these also require a little bit of trial and error as it relates to the input on the macro end. Sometimes you need to not have a space here. You'll see if you try to run the command and it says does not understand. I bet this is not going to work for these ones. So let's see. Okay, ES for extrude surface, EC for extrude curve, PL for polyline. So I'm back in the model here, and before I was typing out polyline. Now, in theory, I could just say PL, and it goes right into the polyline command pretty quick. That's great. Yes, question?
So for instance, you open up a different file.
Yep.
All of that saved?
So you can save, I believe, when you're in a single session of Rhino on the same computer, it will let you duplicate those settings across. But say you're like working on your laptop, and then you're working on your desktop, or you're on a school computer or something, you can actually export out your aliases and save it as a text file. And then what I would actually do is like put that in your email or on Dropbox or in a jump drive or something that you can just quickly load it to whatever interface you're working on. That's the easiest way to do it. So the way that you do that is in aliases, you can click export, and then it will create a text. It's just a TXT file, so it's super light. It's not complicated, but it'll just duplicate this list, and then you can basically import that if you have it saved in an easy location to access. So let's say that we have PL. Let's say that let's see if extrude curve worked. So in that particular case, it did. So it's a lot easier than typing out extrude curve. Now I can type ES. In this particular case, look, it says unknown command surface. So it looks like it got to, in the same way that when we type in extrude, the first thing that comes up is curve. So I was fortunate in this case that my shortcut for extrude curve happened to be what this was. But if I actually wanted this to be extrude curve along curve, it wouldn't have worked. Because as soon as there's a space, it ends the command. It ends the macro. So let's go back there, and we can edit this accordingly. So we should be able to say for extrude curve, let's actually mimic what it's saying in the text line here. So extrude CRV, and that's one line. So the same thing should work for extrude surface. It should be extrude SRF, I believe. So we click OK now, and I type ES. That has worked. It's extrude surface. So there's a little bit of trial and error with like getting the command to work, but I would encourage you guys to go in and program that sooner than later with your preferred kind of workflows. Stuff, you're going to notice it very fast, like stuff that you constantly are coming back to that you're having to either type in or search for a button of. This is going to be, it's going to make your life a lot easier. So creating a couple additional elements here. Oh, scale 1D as well is a total. You might have seen me typing in S1 this whole time. S1. Oh, thank God. Okay. Now if I type S1, quick and easy. I have a roof layer. I should make a roof layer. 3D roof. And that one actually does not want to be inside, so he's been moved out. Change the color. Oops. So you get the idea. So a couple other things that we could do here. Let's say that I'm going to delete these columns here. Let's say that this column is actually a fairly complicated geometry. It's not just a cross. Let's say that it has, maybe there's like a sequence of little like bubbles or something on it going all the way up. I don't know why. I don't know why that would be, but let's first orient our C-plane to this edge. Let's draw, we could draw an ellipsoid here. Yeah, let's try that. So I'm just drawing a kind of a wonky shaped ellipsoid based on the inputs that it's giving me. Some of these 3D surface commands, again, I encourage you guys to kind of work with on your own. That is I have selected that base, so that was moving with me. This is, again, a good reminder to work in multiple viewports just to understand that you're not messing something up. So I'm going to Boolean difference this. Let's copy this. Boolean difference this thing. And so you'll also notice the reason I'm making copies when I Boolean difference is that the Boolean difference object is removed then also from the scene. So in this particular case, I made 2 columns. That column happened, the second column I just happened to use to cut off the back of that ellipsoid, which is a little bit inefficient, but ultimately then the entire copy of that column was removed because it was the reference point for the Boolean difference. So that's just something to keep in mind. Don't Boolean difference your object using a piece of geometry that you want to keep in the scene, because it will be gone. I'm going to match layer. So then let's say that we want to array this up the side of this. I'm going to go back to C-plane top. We're going to array it. Number in the x direction is 1. Number in the y direction is 1. Let's say there's 25 of these. I don't know where this is going to go. We'll see. Okay, so I'm spacing this out accordingly. All right, that's fine. And then let's say there is some strange extrusion off of one of these things for whatever reason. Match layer. Okay, so now I have this object, this column that is, it took a little while to make this. I could copy this over to the locations that I had previously created, but say later down the line I decide I want to change the shape of this column or change the level of detail of it, and I don't want to have to go back through and delete everything and copy everything. So this is where a block becomes useful. So I'm going to select all the objects that I want to make a block out of. A block, basically similar to CAD, if you're used to a CAD block, it lets you edit the block in place and then you can populate it in the scene accordingly. So block, in this particular case, block base point, we'll just make it here. We'll call this crazy column. Okay, so now I've created this block. So right now, a couple things to note. Excuse me. Thank you. A couple things to note about this. Again, just like if you're familiar with it in CAD, it will default, when you create the block, it defaults the layer that it's on to whatever was clicked. So in this particular case, obviously if I were to go into edit this, the basic layers are in the column, column structure that I had made. But if you want the block kind of parent layer to be associated with that, you'd have to make sure that you're on the structure layer or you go through and you manually change it. So in this particular case, let me copy this over. Copy this along. Select a couple of these, copy these over. Looks like I missed 2. That's okay. Okay, so I've copied these all over, but say then I realize, I want to change this. This is, again, if you've ever made a block in CAD, you know where I'm going with this. I can double-click the block, and it will basically open up in the scene. It's desaturated everything else, and it's just highlighted the geometry that is currently part of that block instance, called crazy column. So in theory, I could add objects to this. I could model more objects off of it. Say I wanted to copy this over, add another one of these. Maybe they mirror to the other side. You get the idea. So now, if I were to save this, it's going to populate, it's going to add that geometry to all of the other blocks that are still named that block. So another thing to note is I can edit the location of the block. This can get a little bit a little bit tricky, but basically the location of the block that I set the base point of was here. If I set it out here, and then I click OK, it's going to shift all of those columns over whatever that distance was that I set, right? So be mindful when blocks are very powerful and useful for layer organization, especially if you have a complex system, but that's made up of a lot of simple or repetitive parts. A block is invaluable, but it's important to be mindful of where you're setting your base point and be mindful of what objects are actually part of that block. And so again, it's very easy to remove an object from it. I could add an object to it, just like the hide command. So we should be able to, let's click OK, and now the block itself is actually this. So that's been populated everywhere. So it can be a real mess if you're not keeping kind of an organized eye on it all. Those are blocks, very useful. Block edit manager is, or block manager rather, is where all your blocks will live. So in this particular case, we just have this one, but say we had two or three different columns, all that stuff is going to show up there. Or if there's, more often than not, when you have imported CAD from outside of something that you've made yourself, or perhaps you've made it yourself, blocks are deeply embedded in a detailed CAD file, so those will show up in the block editor. That's geometry that will not register as a line work in Rhino. When you pull it in, it will register as a block. So you can select it as a block. You couldn't select it as a curve, say. So just from a selection standpoint, that's good to know. A couple other ones that this is not going to be Barcelona related, but let's say we have. I almost want to start a new file here. How much time do we have? All right, I'm going to spend like 10 minutes just doing a quick little like contour exercise, which ultimately might be useful to your guys' representation with your topographic models. Again, I don't know where the intentions for that is going, but if you do decide that you need to represent that in drawing, a couple nice ways to do that are, I'm going to delete this now. I don't think we need it anymore. So, okay, let's say that we have a set of topo lines. I'm just going to draw some random lines with this curve, the 3-point curve, control point curve button here, kind of near our C-plane here. And I'm just going to kind of freeform it. So we'll trim this up and clean it up in a minute. But holding down Shift, I'm just kind of drawing through a sequence of lines. I'm going to make a couple of them that are kind of different. Maybe there's some that are closer, kind of mimicking a very simple topography. Everywhere I click, there's a control point for this. Okay, so I have these lines. All right, they're all flat right now. Let's say that I actually have some information about them that I'm able to measure, some topographic information that's from a site survey, or a series of elevation lines that I can actually adjust where these move to start to set up the contour situation in a more accurate way. So let's say that this is my kind of zero line. I'm going to move this up a foot for now, just to take a look at it. So I'm going to type move. And remember our vertical designator to restrict movement of the line from earlier. We type in V so that now this is only going kind of in the orientation that is perpendicular to the C-plane. We'll move this up. Let's move it up a foot. Let's move it up 2 feet. Vertical, yes, 2 feet. So we could go through and kind of do the same operation for each of these. I can move this up 4 feet. I can move this up 6 feet. And again, this is not the most efficient way to do to kind of adjust these topo lines, but this is just one quick way to kind of take a look at this. V, 10 feet, 12 feet. pretty steep. So now I have these topo lines, or I have these lines that we're going to turn into maybe a quick little landscape here. So I could take these lines, and the sequence in which I select them is important. If I were to select these lines and then type the command I'm going to type, it won't necessarily work the right way. So I basically want to, from right to left, I want to select this one first and this one last and everything else in the sequential order kind of that we have it. So you can do that in 3D, you could do it in 2D. I've selected all these lines. Now I'm going to type loft. So what loft does is it actually connects multiple sets of lines, kind of extrapolates a surface out of them that flows down to connect all the points. So you might notice right away that there's a kind of a wonky sequence of isocurves here that are connected, that are connecting this in a way that is like shifting the geometry in unsavory ways. It's just not very smooth. So rather than, I could rebuild here, or I can show you manually how this works just so that we understand what we're doing. I'm going to cancel this command. We're going to turn points on, and you're going to see that on each of these lines, just because of the nature in which I drew them, it's a little bit haphazard where these control points are. So what the loft command is trying to do is connect through these control point paths logical sequences of extrusion. And in some cases, there's more control points on some lines and less on others, and the geometry is just, it's not regulated against its neighbors. So a way to simplify this so that the loft is cleaner is select these lines and click Rebuild. And what this is going to do is there's a degree of not inaccuracy, but kind of, yeah, there a little bit, where it's going to deviate a little bit from my original, where I originally drew it, if I keep the point count at what it's at and the degree at what it's at. If I were to say, this is 200 lines, or 200 points rather, the deviation is going to be pretty light, almost nothing. Maximum deviation is really little. But if I only made each line is now going to have 3 points, the deviation is going to be a lot bigger because there's only 3 control points that it's drawing through, right? It's drawing through an endpoint, and then 1 point in the middle, essentially, that it's pulling, right? So let's say that each of these lines, just so that they're all consistent, have 25 control points. So now if we turn points on, F10, all these are more or less, well, they're equal in terms of the number of lines that they have. And it's just a little bit cleaner in terms of, yes?
If you wanted to do different points for each line, you would just click on each one.
Correct.
Separately?
Yep, correct. So now that these are all, they're not exactly lined up, but they're at least a little bit more consistently built. So if we were to loft this now, oops. So now it's a much smoother situation, right? It's a lot more accurate. You get maybe the subtleties of whatever hillside this is much better than you would have had in the previous case. So you should be able to rebuild the curves right within that command, kind of how we did it. If I wanted to rebuild this with 10 control points and then click Preview, it shows me kind of essentially what we were looking at in the manual rebuild command. So I could up the number of this if it didn't feel like it was accurate enough yet. I could add, I could go to 100 and it's really dense. But it also then adds to the accuracy because there's that many more essentially control points to allow those curves to align to, right? So I'm just going to keep it, we'll keep it at 25 or whatever it was at. Say OK. So now we have this surface that is lofted in one particular way from the loft command. I'm going to copy these lines over just to show us an alternate way to do this. If we loft, there's several ways to sequence this. So I had normal style loft this. I can loose loft, which got to click Preview sometimes to see it. It'll run through those control points in a slightly lighter way so that the gradation is a little bit softer. You can tight loft it, and that's going to be, again, even a little bit more rigid compared to the normal loft. You can do a straight section loft, which allows you to, these are all in theory, well, there's some double curvature here, but it's closer to like a developable geometry where each sequence ends directly at that line and kind of has a flat jaggedy series of edges. You can make it a developable surface, which we can go into the details of that in another session. But basically, what this is trying to do is say, okay, if I were to flatten this object out and then print it and then try to rebuild it in 3D, this is how it would have to be done. So in this particular case, as you can see, some of these are incredibly complicated because of some slight double curvature, which is inherently impossible to build in 3D without extra tools like a 3D printer or something. That if you were to just take a surface and unfold it and make it out of a piece of paper, it's difficult to create a surface with multiple curvature. So that's what a developable surface is. Basically a surface that like if I were to say, if I were to take a box and unroll all the pieces, it's obviously going to just create a series of flat planes, and I could rebuild that really easily. So uniform, again, it's just all little variations of what of kind of that baseline. So let's say we just stuck with the normal curve. So now I actually want, let's say that I wanted to make an actual kind of a site base out of this. So I'm going to go into the top view. I'm going to make a rectangle that is going to trim this basically to an extent that is boundable by flat sides. So let's trim this a little bit. Okay, so I've made a shape that is in 2D directly within the crosshairs of this surface. I can extrude this up. In this case, I don't actually want this to be closed. I want this to be open. So I have this surface here, and now I can actually split this surface using the open box that I made, right? I can delete the box, and now I have a slightly cleaner shape. Let's hide these around the edges at least. Let's hide these curves. I'm going to group them, and I'm going to hide them. So now I could also duplicate the edges of this, duplicate border edges. And what I want to actually do is create a series of lofted, flat surfaces along the side that follow the shape that I am showing here. So I'm going to explode these so that I have 4 separate curves, or in this case it looks like I had a little sequence there. So I'm going to join that together. Let's make sure that this one is all joined. That looks good, and that looks good. All right, so now I'm going to explode this as well. So now I can actually loft kind of one at a time these surfaces, and they're just flat, and they keep it closed. It's nice and clean. Okay, so now we have a whole shape that we can join together. In theory, we could cap the bottom of this. Again, if this wanted to be 3D printed, we are very close to being able to do that. So that's a joined surface there. In this particular case, I want to do one more thing to this surface here, because I don't think that the topo read is actually very good outside of the geometry. If I were to take this outside of the model, it'd be hard to represent this with line work. There's just not enough line work represented through those base curves that I drew. So I'm going to select this surface, and I'm going to type contour. So what I can do here is I'm going to let's just start at the base of this. But let's make sure that our contour plane is oriented vertically. So I'm going to reorient the C plane to just world front so that we at least have a vertical orientator for what I'm about to do. I'm going to start my contours down here, and I'm going to say the contours, they want to run vertically, cutting through this object at a discrete increment that I set up. So I'm going to say direction perpendicular, great. Now I'm going to say the distance between the contours, let's say it's 3 inches. So basically then that has created, only analyzing that surface, a more detailed and I think more visually interesting set of lines that lets you read that as a interesting geometry or an interesting topography or landscape that you could represent outside of the program in a nice way. So if you needed to, you could very easily we could flatten this line work. This is something I wanted to get to. This is more involved. But you can make 2D. This allows you to export line work to other programs. So if you type make 2D, anything that's on the screen that's selected will essentially turn into flat lines and project itself to the C-plane so that you can export that as a drawing. So if I type make 2D with the selection, it brings up this sub-menu and it says, okay, you want just the current view to be drawn, and there's a series of other options here. I can maintain the source layers so that I could easily change stuff in Illustrator later or whatever program I'm going to work in, if I'm going to work in CAD or something. I could show hidden lines if there's a sequence of objects that are underneath the topo lines. And I could show tangent edges. There's just a lot of options for this, but I'm just going to keep it as the baseline here right now. I'm going to click OK. And so now what this has done is, in top view, it looks the same, but actually in perspective, it is a flat projection of the three-dimensional object. So what's nice about that is I can now take this, I can isolate this if I want to, and I could add this to a drawing in a very easy way. Let's say that there's some set of structures that are on this that are meandering down. And I should be able to, again, pretty quickly, this is very done with a low degree of accuracy, but you get the idea. Let's orient these a little bit differently. And then if I wanted to, I could come in and I could trim the sequence so that these objects are kind of showing up, again, as kind of a site plan or a roof plan of some objects in the scene. And then very quickly I could get this out to Illustrator or another program. I can attach line weights to all this stuff. It's live geometry. It's just flattened. So it's a nice way to do. You could create a series of diagrams with this. You could copy this over right in Rhino and show maybe a drainage path. So you could draw lines over the top of it that show the flow of water or something like that, and add arrows to these later. You could show sun orientation. You could do a lot of things very quickly. Whatever. You get the idea. Questions on how to construct that?
Can you show again, how I understood everything, but I don't know why I just got lost with when after you lofted, you created planes around it?
Yeah, that was also a loft command. So it was actually just a loft command with 2 lines rather than 10 lines. So I did the same thing here and here as I had done before. Yep, exactly. Yeah, question?
What was the command you made to make that nice?
The contours?
Yeah.
Contour. Yeah.
Oh, wow.
Yeah.
Do you always have to use this oriented C-plane to go through and vertically?
You don't. You don't have to do that. You could have, we could cut the contours the other way if you wanted to. You wouldn't have to change the C-plane. It was just a quick, easy way to make sure that we were pointing vertically. It will cut it, though, based on that C-plane orientation. If you don't give it an override. Like, since I had a vertical object here, like that I could say, okay, I'll just say I want it to start here and go up to here. It's a vertical line, right? So it's setting that point. But if I set the C-plane to kind of a random orientation in the scene, it will cut those lines based on its orientation to that C-plane. So again, this kind of conventional. Let's see if we can do it one other way, just to prove the point. So again, I would find this, or I would think this could be one way to represent shifting geometries, folded paper maybe, I don't know, or something else in plan to give it a little bit more, to give one a little bit more understanding of how it works in plan. Contour lines could help, give you a sense of that. So we are reaching the end of our time here, but let me see if I can do one more contour situation, just so that we, oops. So let's say let's say the C-plane is oriented to like a random dip in the I don't know if this will work, but it should orient it kind of like, yeah, see it's kind of like slanted. All right, so now if I were to do contour base plane there, but then only go along where kind of the C-plane is telling me to go, which is kind of at this slant. And then I type 2. It might look similar actually, just because we're still cutting through, you know, the same kind of grain. But you see that it's actually, it's closer to being incident with the surface. So actually that density of cut is much higher, because even though we did it at 3 inches, it was 3 inches, but again, in a projection that was angled to that surface, right? So if we reorient this back to 0 and do the contour again, like we had before. So let's say I have my vertical there, right? So now it knows that everything is projected from a baseline that allows the 2-inch increments to be read actually to the vertical, rather than at an angle to our vision, but at a vertical to the orientation of how that C-plane was set up on the other one. So if I type in, like we said, 3 inches, it should read much, it's still pretty dense, but it's less dense. So the orientation of that C-plane is how the contours work. Any questions generally about that?
So would the other one be more accurate when it's oriented as like on a diagonal?
Well, not necessarily, because for our sake of measuring in a site plan, right? Like you still need to have certain benchmark lines that are related to an absolute elevation or a sea level elevation or something. And those lines, as a result, still want to be related to something vertical. So I think the first way that we did it was technically more accurate. Yeah.
Okay.
Yeah. So I'm going to stop there.